Hello everyone, my name is Priyanshu and today I will be explaining bubble sort. So I have taken an example of an array here and I will explain you how we can perform bubble sort here. So the main core logic of the bubble sort is to push the largest element to the last by doing adjacent swaps. So push the largest element to the last by doing the adjacent swaps. This is the main core logic. So what we have to do, just we have to check which is the largest element here. 7 6. 7 is the largest element, so we have to we have to push the largest element to the last. So we will do adjacent swaps here. So 7 is greater than 6. Now we will perform swap. So we can see here, so 7 is swapped here, and we have to move the largest element to the last index. So we will keep swapping the adjacent elements. Okay, so we can see here 7 and 4 they are swapped. So in this first pass and the third iteration, now 7 and 3 is also swapped. So in the first pass we can see that our last index is sorted. I mean the last index is the last index element is at its correct position. Okay, now we have to perform the same operation from up to the last second index. In the first pass, what we have done, we were checking the whole array from 0 to the last index and swapping adjacent elements so that the largest element can be pushed to the last index. Now in the second pass, we will just iterate from 0 to the last second index, because our in the first pass in the first pass our last index is already sorted, so we don't have to take tension of the last index. Okay, it's sorted. Now from in the second pass from 0 to the last second, we will do the same. 6 and 4 are swapped. Now 6 and 3 are swapped. Now we can see 6 is also at its correct position. Okay, so now 6 and 7 both are sorted and they are at their correct position. Now in the third pass we can see that 4 and 3, 4 is greater than 3. Now we have to swap it. 3 and 4 are swapped. Now just we are seeing that our whole array is sorted. What we have done here, we have just pushed the largest element to the last index by doing adjacent swaps. So now I will be going through an implementation. This is a GFG portal. Okay, now I am declaring the size of the array as n is equals to arr dot size. Now I will run the for loop. This will be outer for loop and we have to run from I is equals to n minus 2 up to I should be greater than 0 and I minus minus, because in the outer loop what we will do, in the outer loop we have to, this outer loop I will tell us up to which last index we have to perform the swap elements or check the swap, perform this swapping, because in the first pass we have to iterate the whole array. So here we have to go to the whole array. So here what I have done, I have started from n minus 2, because n minus 2 is this index, this where 4 is written. So in 4, when we will come at 4 in the first pass, we will just check 4 and its next element. So So this way we have to just go n minus 2, and in the second pass we will just check the array up to the last second index. So this way I will started from n minus 2. Now inside for loop, what I will do, I will go from the first index. This is for performing the swapping elements. Now this will go till the ith index. Okay, plus plus j. Now if any element is greater than the element of its next index, what we have to do, we have to just swap it, arr of j with arr of j plus 1. Okay, now we can see that it will compile and run correctly. Let's submit it once. So we can see our problem is solved successfully. But here we can see the time complexity. The time complexity is big O of n square in the worst case. And we can say also the average case. And what about the best case? In the best case, what we can do, we can do sorting in just big O of n. Do you know how? I am telling you. We can just create a variable did swap and just put it as false, and whenever any swapping occurs we can say yes, the swapping has occurred, and mark it as true. Now when we will come out of this loop and we will check if swapping is not occurred. If swapping is not occurred, we can directly say to break from the loop. This way, if our array is already sorted, then in the best case it will give us the time complexity of big O of n, and space complexity we all know is big O of 1. So if I tell you why this O of big O of n in best case, because see what we are doing, we are just going from 0 to the very last index and we are just checking the window, and we are every time just reducing the size of the window. First the largest window from 0th index to the last, then reducing the window one by one. See n minus 2 it is reducing. So see, if any window, if we check, if we haven't swapped any element, it means all the elements are already sorted. It means the window which is whose size is less than the current window is also sorted, because if the bigger window is sorted, then the smaller window which is part of this bigger window is sorted. So that's why we should not go and decrease I and check every window which is smaller than the current window. So we can simply check if we haven't swapped any element, it means the window is already sorted. So we can break because all the smaller windows are also sorted. This way we can check the space best case time complexity is big O of n and space complexity is big O of 1. But in the worst case and the average case, the time complexity is O of big O of n square. Now, if I tell you one thing more about it, it's a stable sort algorithm. Stable sort algorithms means that it maintains the relative order of the elements even after sorting. Okay, this was all about bubble sort. Thank you.